Good day, everyone. Welcome back to another great section of this great tutorial class. Today we are going to be looking at a very important topic, notation in mathematics, and we are going to be looking at sigma notation precisely. Now, before we go into this class, if you know you have not subscribed to this channel, please ensure you do so now. And please don't skip any part of this video in order to get the full details of everything we'll be doing here. See, we are trying to help you so that you'll be able to get the full knowledge, the full understanding of this sigma notation. So we love you. I'm sure you will watch this video to the end. Now, what is the meaning of notation? Notation is just a way or just a shorthand form of writing mathematical expressions. And we have different types of notation. One of them is sigma notation. What is sigma notation? Sigma notation is a type of notation used when adding items or when adding informations or when adding data or when adding numbers together. So when we are talking about addition, that brings us into the sigma notation. So sigma notation is another name for addition notation. That is notation used for adding data or adding numbers together. So please, before we go, ensure you follow the class rule. Don't distract yourselves, please. And now, we said sigma notation is a type of notation used when adding numbers or adding data together. We use to shorten the expression. For example, now, let's say we have this question 1. It said, let's say the question is express the following expression or write out the following expression in notation form or express the following using the appropriate notation or using the sigma notation. Now, if they ask you to write out the following using the sigma notation, you know that as far as we're talking about addition or summation, that is where sigma notation comes in. So, there are some questions that will come to you. You will not hear anything like sigma notation in the question, but as far as you are saying plus or minus in the question, we are talking about sigma notation. So let's look at this first question now. We're having 1 plus 2 plus 3 plus 4 plus 5. Now, we have to call integers in mathematics. Integers are just whole numbers that can either be positive or negative. Now, if you have an expression that contains just integers, and want to represent them in notation, you are free to use a single, you have properties of a notation. For example, now, this is called the lower limit, this one you are seeing there. Then this 5 is called the upper limit. Then this n you are seeing here is called the index number. Then this symbol you are seeing here is called the sigma notation. So if I want to spell it out, I'll just put this symbol there. So anytime you see symbol like this, anything like this, it means sigma notation. So any number here, let's say I start from, let's say 2, I end at, let's say infinity. So this 2 is called the lower limit. Then this symbol here, any number there, that is infinity there, is called the upper limit. Then any number in this place, let's say 2i. So this one is called the index, this I here is called the index number. Let's all call that one. Now, index number is the kind of number used for items that can assume any value. For example, if you look at this series, or if you look at this expression, that's like it's not just one number. We are changing from 1 to 2 to 3 to 4 to 5. So anytime you see something like this changing from one number to another, if you want to represent them in notation, you must use an index number or a number called, we call it index number. Why do we call it two decimal? Because it's not just one value. It's like a variable. Something like that. Just like a variable that can assume different number 1, 2, 3, 4, 5. That's why I put n here. So n can take 1, n can take 2, n can be 3, n can be 4, n can be 5. So any number can be n. That's what we call the index number there. So please ensure you know it. And look at it. We can have expression that will have integers. Integers just means normal whole numbers. Let's say 1, 2, 3, 4, 5, 6. Move in that order. Then we also have odd numbers. Let's say 1, 3, 5, 7, 9, and so on. We also have even numbers. Let's say 2, 4, 6, 8, 10. What do you mean of odd numbers? Odd numbers means numbers 2 cannot divide. What do you mean of even numbers? Even numbers means numbers 2 can divide. What do you mean of natural numbers? Or what do you mean of integer? Integer means normal whole numbers you know. Like all those 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 1, and so on. They are called integers. So those normal numbers you know, they are called integers. Then the 1, 2 can divide are called even numbers. The 1, 2 cannot divide is called odd numbers. So if you have a set of odd numbers and you want to use an index for the odd numbers, so you are going, please ensure you use this, something like this, in a very simple for simplicity sake. Use 2n either plus or minus 1 or any other odd number. It can be 1, can be 2, can be 3. But ensure that what is here will not be odd number. Then if you have a set of or a series or an expression containing even numbers, use just 2n plus 0, we just 2n, or 2n plus or minus even number. 2n plus or minus even number. So for odd numbers, use 2n plus or minus odd. For even numbers, use 2n plus or minus even numbers. So I will just say, let's start with this. For odd numbers, use 2n minus 1. But this minus can be, this one can be also be plus 1, and the case will be. Take note of that. It's not just be 1. No, it can also be plus 1, it can also be plus 3. As far as what it says odd, you still get it correctly. Therefore, even number, just use 2n. We can use 2n plus 4, 2n plus 2, 2n plus 0. 2n plus 0 will give you 2n. And so on. Please take note of that. It's very, very important. And that's why when you see this one, 1, 2, 3, 4, 5, this one is just integers, positive integers. That's why they're just using n as the index there. So look at what I'm trying to say. Let's say we have this one 1, 3, 5, 7, and so on. Now, these 3 lines here, they are not in this question. Take note of that. So if you want to do this one, because this plus there, therefore say add together using this notation. Then, what are we adding? An expression that contains, is it just ordinary integers or is it number different from integers? Now, these are whole numbers. Types of integers called odd numbers. They are odd numbers. It's not just ordinary integers. These are odd numbers. Because it's 1, 3, 5, 7, and so on. Numbers 2 cannot divide. So, if you want to represent odd numbers in form of index, use 2n minus 1, or 2n plus 1, or 2n plus any odd number, or minus any odd number, and the case basically will be. So, now after you have used this now, then where we can start from? Because this n is the only variable there. This n will start from 1 and end at, let's see, 1, 2, 3, 4. But look at this, you have 3 dots here. It means the thing will not have ending. It's going to end at infinity because of these 3 dots. Now this one don't have any dots, that's why it's ending at 5. So these 3 dots means end at infinity. That's why it will end at infinity. So you want to check that correct. If we put our 10 is equal to 1. You put 1 here. 1 times 2, we have 2. Minus 1, we have 1. That is. So our 10 is equal to 1 now. We have this first value. Our 10 is equal to 2. Look at this. This 10 now is 1, 2, 3, 4, till infinity. So our 10 is equal to 1. We have this first number that is called first 10. Our 10 is equal to 2. We have this second 10. Our 10 is equal to 3. We have this fourth 10. Our 10 is equal to 4. We have this fourth 10. So let's check. Our 10 is equal to 1. Put 1 in here. 2 times 1. 1 minus 1. That's 2 minus 1 gives us 1. Thank God. Then let's go to this. 2 times 1, 2. 1 here, 2 times 1, 2 minus 1, that's 1. Then our 10 is equal to 2 now. 2 times 2, 4 minus 1, 3, correct. Our 10 is equal to 3, 2 times 3, 6 minus 1, 5, correct. And then go to 4 times 4, 8 minus 1, 7. See, it is very correct. Very, very correct. Now, let's go for this. Now, you check, you have 2, 4, 6, 8, 10, 12. Then, these numbers, the numbers there are even numbers. Remember to set to the even numbers are numbers 2 can divide. So, we are adding. Since you are adding, you just add together is an expression of what? Even numbers. So, you use 2n to represent that for even numbers. Then, remember for even numbers 2n. For odd numbers, use 2n minus 1, or plus 1, or plus, or minus any other odd numbers. Any other odd number. You also use 2n plus or minus even numbers. This one. But 2n will work in most cases. Then 2n minus 1 will work for odd numbers in most cases. In most cases as well. So let's check now. Set 2n for even numbers. Then from there, let's see what we're going to get. Now, this n we are talking about, because 2 is a value, but n is a variable. N can be value. Now, what is n? Let's say n will start from 1 and end at 1, 2, 3, 4, 5, 6, and end at 6. So you now say, okay, let's see if you are correct. And then it's equal to 1. Put 1 there. 2 times 1. We have 2. Very correct. And then it's equal to 2. That means this one means n will be 1, 2, 3 until you get to 6. That's the meaning. N will start from 1, 2, 3 until you get to 6. That's the meaning. So as n is equal to 3 now, that gives us 1, 2, 3. The third 10. 1, 2, 3. We're going to have 6. Let's check. 2 times 3. And then go to 3. 2 times 6 is 6. Very correct. So please, let's do that. Okay, let's do for this other one. So we are adding the symbol, add together. Look at it, we have sin here, sign is not changing, so the thing will remain the same. Like something is not changing, it remain the same. We have x is not changing, it remain the same. But what is the change actually? The quantity of this x is 1x, quantity of this is 2x, quantity of this is 3x. We have 1, 2, 3. Just like we have here 1, 2, 3. So the coefficients of these x now are changing in form of integers. So in order to represent integers in form of notation, we use just n. We're going to have sign nx, and n start from what? Let's say start from 1. Start from 1. We'll check. And let's go to 1. 1 times x, we will have x. Very correct. Then we now end at, because these 3 dots, it's going to end at infinity. So n start from 1 and you it's going to end at what? Infinity. So let's check this next one. Let's check this one. The same thing. Somebody same thing. Sum together. We have sign here. Sign. We have x. Sign x. Sign x. If you check, we have 1x, 2x, 3x, 4x. You check very well. The coefficients of the x are changing. So see, the coefficients are changing from one value to another. And you check how is it changing? Is it odd, even, or power, or exponent, or just integers? And this one is changing in form of just normal integers 1, 2, 3, 4. For normal integers, we use n to represent that. Then let's check. This one is minus sin s plus sin s minus sin r. So if we have minus plus, the signs are alternative as well. The sign are alternative, so we are going to work on that. So let's do for this one first to get it. We are going to have n start from, now we have just one s here. So we are going to start from 1, 2, 3, 4. These are going to have 3 dots, so it's going to end at 1, 2, 3, 4. We have 4, 10, we end at 4. So I think it's equal to 1, we're going to have sign 1s. But this one is minus here. That's another problem we're going to solve here now. This minus there. So we have sign 1s, I'm going to 2, sign 2s, I'm going to 3, sign 3s, but look at minus. That's another problem. But take note of this. Take note of this, it's very important. If you have minus 1 raised to our even number, that's how we plus 1. If you have minus 1 raised to our odd number, that's how we plus 1. That's what. So 1 is an odd number, 2 is an even number. In this place now, our n here is equal to 1, 2, 3, 4. That's what we have here. So for the first one now, we can say in the back of this place, we say let's put minus 1 raised to our n here. What are we doing? Look at why we are doing it. If n is equal to 1, Minus 1 raised to power 1 will be minus 1. Why? Because minus 1, because 1 is an odd number. If you have negative 1 raised to power odd number, it will be minus 1. So if I put minus 1 raised to power n here now, if n is equal to 1, we'll put 1 there, put 1 there. We're going to have minus 1 raised to power 1 sine 1x. That will be minus sine x. That's what we're going to have. Then as n is equal to 2, you put 2 here, put 2 here. Minus 1 raised to power 2. 2 is an even number. So minus 1 raised to power 2 will be plus 1. And plus 1 multiply anything remain the same. Then put your total have 2s. Correct. Then at n is equal to 3. Minus 1 raised to power 3. 3 is odd. It will be minus. Then we'll have minus here. Then you put 3 in this other place. Then you put 3 here. Then we'll have 3s. Correct. At n is equal to 4. Minus 1 raised to power 4. Even. 4 is even number. That will be plus 1. That will be plus. Then if we put the same 4 here. We have 4x. So this is the correct notation. This. Then let's look at the next one. This one is the addition, sum together. The values of, look at that 2 is not changing. So since it's not changing from one value to another, you are free to just put the 2 remain the same. Then what's actually changing? The power of the 2. This one, anything that power have the value power is 1. And you can write it there. Yes. 1, 3, 5, 7, 9. You check the power, it's changing in form of odd number. So what you do in this place now to unravel this mystery. So if you are having odd numbers in your expression, how do you represent them in notation? So you use what? For odd numbers, you use 2n minus 1. That's how you use. That's what you use for odd numbers. Lose bracket, or you don't leave it like that. So what I will have, n will start from, this n will start from 1 and end at 1, 2, 3, 4, 5. And end at 5. So let's check to see if we are actually very correct. I think it's equal to 1. 2 times 1, 2. Minus 1, 1. Very correct. I think it's equal to 2, 3. That is, n will be 1, 2, 3, 4, 5. Let's end at 5. Starting from 1. I think it's equal to 1, 2, 3. Third 10. 1, 2, 3. Third 10. I think it's equal to 3 now. 2 times 3 is 6. Minus 1, 5. Correct. I think it's equal to the last one, the fifth 10. 2 times 5, 10. Minus 1, 9. And the last one. So we are very, very correct. You see, as I'm writing the notation, I'm testing it. So that's how you write notation. You write it, test to see if you are actually correct. So this next question said, what is the fourth term of this series? This one not the notation is already written. Now let's for you to just state the fourth term of the series. So let's take it to see. Look how to do it in a very short way. Now, if you want to do this, you may decide to write out the notation. But if you want to do it in a very short way, you just know. Okay, let's not write it out. In this question now, our I is 1, 2, 3, 4, 5, 6, until you get to 10. That's what I have as I. So our I is equal to 1. Anyway, see I here, put 1. So we're going to have 3, 1, minus 2, and plus. Our I is equal to 2. Anyway, see I here, put 2. 3I minus 2 plus. How many is it plus for? Because of this sigma notation. That's why if I put I for the first one, 5 is equal to 1 plus. So put them with plus. Because of this sigma notation there. Then our I is equal to 3. Equal to 3. We have 3 bracket 3. Then minus 2. Then plus. Our I is equal to 4. We have 3 bracket 4 minus 2. And plus, our I is equal to 5. 3 bracket 5 minus 2 plus, our I is equal to 6. 3 bracket 6 minus 2. Our I is equal to 7. Till you get to I is equal to 10. 3 bracket 10 minus 2. If you want to write it like this, no problem. So you'll be having 3 times 6 minus 2, that's 1 plus 3 times 2, that is 6, minus 2. So you're having 4. 3 times 3 is 9 minus 2, you're having 7. 3 times 4 minus 3, you're having 10. Then 3 times 5, 15 minus 2, you're having 13. Plus 3 times 6, 18 minus 2, you're having 16. Plus minus 2 times 10, 30 minus 2, 28. So this is what you have. And the first 10 will be 1, 2, 3, 4. That is our first 10. So the first 10 will be 10. That is the question they're asking. So if you write it, good to write it this way, there's no problem. There's no problem. Now look at another way to write that. Another way to write that. I want to clean this off now. So let me play it. Another way to find this 10. I also my favorite write it out in a few words. Because I want to look for the 10. It's very short way. You just come to this I and count to get to number 4. Number 1, number 2, number 3, number 4. Number 4 in this index give us the first 10. Number 4 give us the first 10. So have 4 for the number 4. So anyway, see this I here, you don't put 4. We're going to have 3 bracket 4 minus 2. So we're going to have 3 times 4, 12 minus 2. That's 10. Answer. That's what we are going to have. Simple as that. Simple as that. Now in this example, I say write down the fifth term of the expression. Write down the fifth term of that expression. So let's do that quickly before we go. Now the first thing to do, let's write out n. N start from 1, 2, 3, 4, 5, 6, 7 until you get to what? Infinity. Because n is not going to end. It will end at infinity. So they said, what is the fifth term? What you do, you come to this place, you have n. Just count. 1, 2, 3, 4. Until you get to the 5, that is number 5. We'll give you the fifth term. We are going to go down 1, 2, 3, 4, 5. You don't mark out this. So, at n is equal to 5 now, go to that expression. We have bracket 1 minus x over n. We said n is 5 for the fifth 1, 2, 3, 4, 5. Number 5, give us the fifth term. That is over 5. There is power 5. We are going to have that is 1 minus s over 5. This will be the fifth term of that expression. So please ensure practice this, practice other questions, and the rest. So before we go, I would like to give us 1 to 12 to express this using notation. Express this one using notation. To express this using notation, you have 1 plus 4 plus 9 plus 16 plus 25 plus dot. So if you express it now in notation, express this in notation. What are you going to have? So try and do it to see if you can get the exact answer. Alright, you do it very well. You're going to have this as the answer. Sigma n squared, n start from 1 to infinity. All this thing is going to say that's right, infinity. 1, 2, 3, 4, 5. I think it's going to 5. 5 squared equals 5. So that's this one I don't have this answer. So see you guys on the next one. God bless you all.